Hi there. Question 41 on page 147 at the end of chapter 4. This is for tomorrow, Friday's test, part of the review. So question 41 has a puck which is 30 grams moving across a patch of rough ice. There is friction acting on the ice, on the puck as it slides, and as the puck is sliding across the ice, it's ultimately going to come to a stop. So when it gets to its final resting place, it will stop. Now, we're told that the only force that we can see working on this puck is the force of friction, which is pushing it backwards. Okay, so the puck is rolling forward or sliding forward across the rough ice, and there is friction slowing it down. The friction is the only force that's acting. So if I say, what are the sum of all the forces acting on this puck? Friction is the only force. And we're told that friction is 0.2 newtons. But notice that friction is moving in the opposite direction to the direction of motion. So if I choose the forward motion of the puck as positive, the force of friction is pushing back on the puck, so it's actually a negative force. Okay, so the acceleration now is negative 0.2 newtons. Now, if I look at my data, I have a V1 and a V2. That's all I know. We know that to do any of our equations from the previous chapter, I need 3 pieces of information. All right, so I need to find out something. If I know the net force and I know the mass of the puck, I can also determine its rate of acceleration using F net equals ma. So ma is equal to negative 0.2 newtons. The mass is 30 grams, which is 0.030 kilograms. Hopefully you have no trouble with that conversion. And the acceleration turns out to be negative because it was a negative force. My acceleration is negative 0.20. Force is negative 0.2, so the acceleration is negative 6.7 meters per second squared. Okay, now I know the rate of acceleration. I can use that and the data up top there to determine some of the other parts of this question. Now, if we know that V1 is 10 kilometers per hour, hopefully you have no trouble converting kilometers per hour into meters per second now. Okay, again, remember 1,000 meters is a kilometer and 1 hour is 3,600 meters. So I'm going to take my 10 times 1,000 divided by 3,600 to come up with a V1 of 2.8 meters per second. Now the question is saying, how far does the puck move before it stops? And how long does it take to stop? So I can use any of the equations that I want. I'm going to look at delta D equals V2 squared minus V1 squared over 2a to find the distance, because I know V2 squared minus V1 squared. It was actually negative 2.8. Oh, sorry, no, it was 2.8 meters per second squared divided by V2 over 2a. The acceleration is negative 6.7. So if I take my 2.8 and square it, I end up with the negative of 7.7 divided by 2 times negative 6.7. I'm getting 0.58 meters. There's the distance traveled, and then if I want to solve for the time, why don't we just use V2 equals V1 plus A delta T. And then I know my V2 was 0, my V1 was 2.8 meters per second. The acceleration is negative 6.7 times the time. So the 2.8 goes across as negative 2.8 divided by negative 6.7. And I get a time of 0.42 seconds. So there's my delta D. And there's my delta T.